I am Vitons, and this is Cosmology 201, Vitons and Quantum Gravity. This video contains the core of my theory, which will be developed in further videos. In 101, I gave you an image of our universe as something floating in nothingness. To find out what that somethingness is, we need to go small, very small indeed. I'd like to introduce you to a very large number, 10 to the 20. 1 with 20 zeros behind it. I think I would call it 100 billion billion, but I'm going to call it 10 to the 20. It's more precise. And I'm going to use this number, this huge number, as a scale factor to go from something we can understand to places that are more difficult. This is the closest we come to a human scale. It's 165 kilometers, or 102 miles. This is the sort of distance between two large towns, maybe, in most of the world. If we go from here and multiply it by 10 to the 20, we get to the diameter of the galaxy. And if we multiply that by 10 to the 20, we get to the diameter of the universe as a whole. If we start again from 102.5 miles, and we divide it by 10 to the 20, we get to the diameter of a proton or a neutron. They are more or less the same. And if we divide that by 10 to the 20, we get to the Planck length. This is the smallest distance in our universe. This was developed in 1899 by Max Planck, and the system of units holds its name. There is a smallest energy, a shortest length, and a shortest interval of time. I'm going to call the Planck length a Viton. That's the wrong way round. I'm going to define a Viton. That's the right way round. I'm going to define a Viton as a multi-dimensional thing. It's round. Its diameter in the 3 dimensions of space are the Planck length. So its diameter is the Planck length. Its extent within time is just 1 Planck time, which I'm going to call a moment. And I'm not going to restrict it. There could be other dimensions. I'm just saying that a Viton will be the smallest possible in each of those dimensions. Our universe is entirely and completely defined by Vitons. If anything is made up of Vitons, then it's in our universe. And if anything is smaller than a Viton in any of those dimensions, it's just not in our universe. It's sort of fallen through. It is the fundamental particle. But not all Vitons are the same. There are 3 colours. So I need a new dimension, the 5th so far, called the colour dimension. It's very small. It only has 3 possibilities within it, and I've chosen to call them red, blue and yellow. And some rules. It's always good to have a few rules. It enables things to go with more of a swing. Rules of the universe. Number 1, the principle of balance. I mean, I'm assuming that the universe is in a state of balance. It was created out of nothing in a state of balance, and it has stayed that way, and it can't be any different. So, the first balance that we find is in the 3 colours. When these things were created and are created, they're created in multiples of 3. But when they start moving and changing, they can change in the colour dimension to another colour. And once they start on that rotation, they can't go back. So there's one sort of triad that rotates from blue to red to yellow, and then there must be another triad which rotates from blue to yellow to red. So now they have to be created in multiples of 6. The axiom of change. This means that every Viton must change every moment. And there are two ways for it to change. One, it can change colour. And 2, it can step through time. No returns. I've already talked about that, but in the time dimension it means that it can't go back in time. It can only go forward in time. And the 4th rule, transmission of rays, needs a bit of explanation. When 3 Vitons are different colours and neighbours, they change in the colour dimension, they rotate. It seems like they rotate. Actually they disappear and they reappear as a different colour. Very subtle difference from saying they change. So, when they do this, they send out an instruction, which is the transmission of rays. It's an instruction to the Vitons next to them, this way and this way, also to rotate in the same way, in the same colour sense. So when this one rotates this one rotates that way, and this one rotates that way, and the message gets passed on. Bom, bom, bom. So there are 2 rays that come every time that happens. And they travel at the speed of light, which is, in the units we're using, 1 Viton per moment. But at this scale, everything moves at c, the speed of light, either through time or by changing colour. These rays provoked by the rotating triads are one-dimensional. They don't spread out, they just keep going until they encounter another ray in a head-on collision, which is where things get interesting. If they are of opposite colour rotations, then they stop, and the three Vitons between them get moved aside. So it has the effect of disappearing a little bit of space between the two origins. If they are of the same colour rotation, then they stop and they move three Vitons into the space. So this preserves the balance. And this means that they create a little bit of space between the two origins. And this is enough, I think, to create the universe described in 101. Aha. Here is a representation of a Viton, a ping pong ball. And this is a representation of flat space. This means there's no tension in it, there's no warping in it, it could extend infinitely in all sorts of dimensions, although it doesn't. The originating Viton, the one that I'm talking about, is the one in the middle. And there are 6 around it, 3 on the bottom and 3 on the top. 12 in all. And this is the maximum number of neighbours that a Viton can have. Whereas this is also a collection of 12 Vitons. But if I turn it so that there's 3 on the bottom and 3 on the top, you'll notice that the other ones, they're not in a horizontal plane. They wiggle, they go up and down, and up and down. And this means that the space inside this is smaller than a Viton. The space inside this does not exist in our universe. It's like a pinch in space, a warpage of space. I'm going to call it a kernel. A kernel, I should have a yellow one there, but an orange one rather. But anyway, we'll just carry on with this. A kernel is made up from 4 triads. 1, 2, 3, 4. And each of these triads is rotating in the colour dimension. And so they're pushing rays out both sides. So there are now 8 rays coming out of this triad, this kernel. Sorry. But these rays don't interfere with each other, as I show by this model that I've been playing with and sticking straws in. And you can see that the straw here comes out the bottom and it doesn't interfere with the other three, which it's a sort of, they're arranged in a tetrahedral way. I'll give you a view of a tetrahedron there. 4 things. Everything is symmetrical. So this is a tetrahedron and a tetrahedral symmetry. The 4 triads are all of the same rotation. And they attract triads of the opposite rotation. You can see that if there was a triad here with a ray and the ray from this, the space between them would disappear and finally it would come down. And that happens 8 times. So they form a shell around the kernel. So now we have a bigger object. It's a bit more symmetrical than a kernel because it's got more Vitons involved in it. And it's now made up of matter and antimatter. Because these colour rotations, one way we're going to call matter and the other way we're going to call antimatter. The rays from both rotations can escape, but with a preponderance of those from the shell rotation. And they will attract the kernel's rotation's triads, forming another shell, and so on, in an alternating matter or antimatter, matter or antimatter. At first it becomes more unbalanced, but after a certain point it starts to converge or neutral, each pair of shells coming closer to neutral until a neutron is formed. And although it's neutral, that's only because there are equal numbers of matter and antimatter rays emanating from it. It's neutral, but it's not inert. Energy is radiating from it. And of course, if we started with a different rotation in the kernel, then all these shells that build up will be the mirror image of this neutron, and you will get an object called an antineutron. But I'm going to call them N-bars, because neutrons are usually abbreviated to a capital N, and the antineutron is abbreviated to a capital N with a bar across the top. And I don't want to give you this idea that neutrons are a matter particle and antineutrons are an antimatter particle, because that's not true. They are both a balanced mixture of matter and antimatter. This explanation of quantum gravity depends on the concept of rotating triads. The more rotating triads, the greater the mass, and the stronger the gravitational force. Einstein's theory of gravity, in general relativity, depends on the concept of warping of space. But triads don't warp space, whereas kernels do. So let's go back to this diagram that I left you with in 101. Now these neutral particles are not inert. Now there are matter and antimatter rays. And although they're balanced, there becomes a subtle argument here. When you disappear the space between them, when opposite rays meet and disappear space, they definitely move. But when you create space, they sort of shy away from each other. Like magnets, if you've tried pushing magnets together, they don't push back, they slide away from each other one way and the other. Or you could look at it and say, well, they're both doing the same thing, but there will be a tendency for them to line up so that the matter ones from here line up with the antimatter ones from here, and the matter ones from here line up with the antimatter ones from here, giving you a net attraction. And that is my explanation for quantum gravity. Thank you.